Welcome, everyone. I am Vaughan Huckman, the Chair of Canterbury Tech, and welcome to our lunchtime session. So, background info before we kick off. That's the summit. It's selling very, very fast. One in, I will not wait for that. The ecosystem is up and running.
Sorry, Vaughan, I think your sound might have gone funny again. Can everyone hear you? Is anyone else having problems, or is it just
bit patchy?
Yeah.
Okay, how about that?
Yeah, much better.
Oh, go figure. Right, the Canterbury ecosystem app is up and running, and we want everyone on it. So go check it out. Ecosystem NZ, and there's links to a form there where you can get yourself on the map. So fill it in, start tracking there. There's a cybersecurity micro event that UB are running at the moment that is free, but this is the last tranche that they've got funding for. So if you or anyone in your teams want to get onto that, get in touch with UB. Some other events coming up. We've got Digital Identity, Cyber Security Summit, Electrify Accelerator, and New Zealand Aerospace Summit. And our next in-person event, first Tuesday of the month, 2nd of August, and that will be hosted at Ep right in the centre of town, and talking about financial technology and all that lovely, exciting stuff. And that's our background. I'm going to switch to Ashley from Phocas, and he will tell you all about the world.
Cool. Thanks, Vaughan. Will just let me share screen, please?
And if anyone has any questions, either put them in the chat as we go through, and we'll have a Q&A session at the end.
Hello, welcome everyone. I'm Ashley Taylor. So yeah, I'm head of architecture at Phocas. A little bit about my background. So I went to uni in Canterbury, so I've been in Christchurch since then. So forget when that was now. And I was at SLI Systems about 10 years, and there I was leading the search and indexing team. So back end, trying to build systems that were really high performance, and sort of the constraints of the hardware was always forefront when trying to make searches perform. And some of those techniques have sort of been moved into the browser in this talk. So a little bit about sort of Phocas and how it relates to this talk today is we have a suite of products that really just to help companies make decisions with their data. So what this one relates to here is, so we have a financial offering, which is we've taken all the data from the ERP system, wherever it is, and we're just showing it to the individuals in the company, and they can then drill into it and try to find metrics. And then building on top of that is we know how your business performed last year, giving them a tool to do their budget for subsequent years. So here is a little screenshot of the product. If it wants to move, there we go. So this is what we call budgeting and forecasting. And it kind of works like Google Spreadsheets or Excel Online in some respects, that you can put values in a cell, you can put formulas in, you can reference other cells and stuff. Where it differs is because we have all your financial data from last year, we can use that as your baseline. So we can go, this is how you performed last year, and you can start modifying it as you need. And we can also put like hierarchies in. So if you have different branches, they can all be grouped together. What did that branch, how did that branch perform? And all the visibility rules that you set up in the existing product will flow through, so all those security requirements, and these are built-in workflow. So you can sort of assign things to each other. Like at a really high level, about the sort of architecture of this project is it's a React app written in TypeScript. We have a GraphQL backend that runs on AWS Lambda using DynamoDB as the database. And with existing products, we just sort of use REST API calls. You can almost think of it as like a third-party provider to this product, sort of like if you were using Google Maps, for example, how we interact with the existing product. And to try and make the user experience sort of as responsive and as seamless as we can, most of the logic we do in the browser. So when we're putting in formulas and doing all the interactions here, all that calculation we do in the browser. And this, so how it relates to this talk a little bit about where was the challenge, where was it tricky. So with the formulas, it's reasonably high level, but we started off using Redux for our state management. So if you're not familiar to Redux, it's an immutable state tree. So you can think of that like a big JSON file. You can't have different things point to other nodes, like it's a tree. It all has to come from a root point because it has to serialize. And we have formulas like this one for sales has a value of 100,000. This one has 50,000. Revenue, we're saying sales plus sundry would be 150,000, and then for this we want 10%. So the big challenge is, how do we update this value? How do we say when I've made a change here, that this one here has to change? So the naive implementation is you recalculate everything regardless of change. Works fine if you have a small budget. Problem is, budgets grow, and customers' budget ever increasing size, and the performance just fell down. So what we did to try to overcome this is we put computed state in with our actual state, which in Redux is a bit of a no-no, but this is how we solve the problem. So we're saying, okay, we're actually going to store the computed values on our state. Here we got the 150,000, here we got the 15,000. And when this changes, please make this one recalculate. So we had all of this sort of manual state management trying to go on, trying to keep everything in sync, make sure the user experience is nice. And the development experience, it just got too complicated trying to keep all of the stuff in sync, and the bugs just started to creep in. So like, okay, is there a better way that we can tackle this problem? Is there a more suitable tool to this particular use case? So what we did is we switched state systems, basically. So we went to Mobex, which is a competitor to Redux. Because Redux is a big JSON file, you can think of this. Mobex is like a traditional OO paradigm. So if you're coming from backend development, the developers may be more familiar with the Mobex mindset as opposed to the Redux functional mindset. And in Mobex, it gives you this ability to compute state from other ones, and it deals with all that reference tracking that we had troubles with in our Redux solution. So our model looks like this, and now we have a method which computes value. And Mobex deals with all of the challenges around when should this value be updated, when should the user be notified. Problem was solved. Like, oh, job done, easy from here. So we went along and we had to convert from Redux to Mobex. We decided, yep, this looks good. That change in reasonably large project is such a key thing. It's like, how are we going to actually manage this transition from Redux to Mobex? Redux, really simple contract to meet how it works. We managed to actually just write a layer that looked like Redux using Mobex, and we just put it in. So we changed the entire code base from one state management system to another one with like a flick of a switch, which may have given us an over sense of confidence that we'll get to a little bit later, but we had switched to Mobex basically overnight. So like, cool, problem solved. We could get back to delivering features. So we were sort of building up the application, adding features, and customers started running into memory issues. They were budgeting at way greater granularity than we expected. We were expecting like thousands of rows, not tens of thousands or hundreds of thousands. And the overhead of Mobex and JavaScript was really just starting to bite. So we're like, okay, we have a new problem. And this is just to give you a little bit of a background into like JavaScript's memory management. So if this here is a little bit of JSON that you would see in a browser, how JavaScript has to store this is an object. The outer curly ones is a JavaScript object. And there's some properties on that. Is it sealed? Is it frozen? There's things going on. And then it can store an arbitrary number of values. So it has to allocate a bit of space for the value part, bit of space for this 10.5 number part. And then each of these things can have properties on them as well. So there's quite a bit of fat that goes on in a JavaScript object compared to a statically typed language with structs or something that can be much tighter in its memory usage. So we noticed we were wasting a lot of memory there. And when you take Mobex into account, Mobex with all that sort of magic reference tracking, it's taken our little value, it's 10.5, and turned it into another object with methods that know when everyone calls get, add them to the list of people that care about this. When everyone gets set, you're going to notify everyone that needs to be known, and what's the actual value. So there's an additional memory overhead on Mobex. And we're like, okay, using some back-end sort of expertise, it's like, what's the way we can solve this? We've solved this in other languages in a back-end space before. And what that led to was to go with a column-based layout. So if I have 1 million objects, which are all the same, they all have 3 fields. Instead of allocating 1 million objects, I allocate 3 arrays, 1 million long, and the offset in those arrays recreates the view of that object. So I've taken that object and I'm just sort of pivoting it. How do I store it in memory? This allows in JavaScript to have much better memory footprint. So this column-based approach, if anyone's heard of a library called Phocas, is exactly how that works. It's a big data processing library, and it's just a common industry practice for big data processing, which we sort of moved into the browser. And we wrote our own library to try and hide this complexity away, which we call PGM, stands for Focus Grid Memory. So we have arrays of values, multiple arrays, and then it sort of depends and provides us how we did our reference tracking. It's sort of quite complicated implementation detail, which I won't really get into. So what that allowed us to do with that simple example we had before for 13 million cells, which is about 1 million rows, just having 13 million cells of just a single object with value as a string, that uses about 3 gigabytes a heap. With Redux, being able to do some level of dependency tracking. And in Mobex, about the same, but then every single additional field, you're going to pay another 1.8 gigabytes. And we don't just have one field, we've got multiple fields. So this will just consume all of our browser memory really fast. And our implementation, that base level is about 1.2, and each additional field is only 100 megabytes. So like, cool, we actually have a system that we can iterate on here. This was what we assumed. This Redux one, it will go in steps when it rehashes. So it will jump from 3 to maybe 4 when you get up to 5 arguments. Like the actual behavior would really depend on the browser. Cool. So we had our plan, we had our library, and it's like, okay, now we have to integrate this library into an existing code base. We did that Redux to Mobex one really easy. But now the code has moved, it's a more complicated app, and we want to do the same thing again from Mobex to our custom state management system. And we came in pretty confident because Redux to Mobex had gone so well. But the Mobex way it integrates with your code, it blurs the contract between presentation and state a bit more. The fact that you can put methods in there. It's no clear-cut layer for where do you integrate. Yeah, the code, we had more features, we had teams trying to do more features on there, and there was no easy way that we could see where can we just plug this in. How do we do this? We made it a long-lived branch, and we just tried to do it. We never saw any of these assumed performance or memory improvements in this first approach, and it just sort of just dragged on and on and on, and the team was getting pretty disheartened, and so starting to suffer burnout. And we're like, okay, this approach isn't working. Our first attempt to integrate this new complicated concept into an existing code base just didn't work. And what did we do? We stopped. We said, okay, let's take a break. Let's do something else. We had developed quite a lot of technical debt at the side of this one, sort of pushing decisions out to be dealt with later. Like, oh, once we get that branch in, we'll come back and tackle them all. And the existing code base got messier. So like, okay, we got to actually stop for a second and come up with a new plan. So quite a large team working on this. We had about 10 developers in total in this team. And what we did is we split the team up into sort of much more focused teams within there. And we're like, okay, we got to deal with some of the other fires. We hadn't done a release in a while because it just got a bit scary with all the changes. Like, okay, we got to do a release. We got to increase some test coverage. We've got to get some features that customers are wanting over the line as well. But the big thing we did is we're like, what can we change in our existing code base to make integration for this approach take easier, so we don't have this big long-lived branch? So how can we change what we have without getting rid of Mobex to allow getting rid of Mobex much simpler? So we split the project into modules, and we tried to define contracts. We spent a whole lot of time coming up with what could we do. So then it was like, okay, now we're in a position where we're like, let's integrate this library in again. How are we going to do this the second time to not make the mistakes from the first time? So the difference is we'd already had one crack at this, so we had some ideas where the challenges were. We're like, okay, we're going to have to do a lot more planning up front, identify how do we get this in, and how do we keep the team working on it small. We don't want to just put more people on the problem when you can't manage that level of throughput yet. It's like, I keep the team working on the integration small, and we want to be able to make sure we can actually prove what we're setting out to. We're wanting to show that this will reduce memory. How do we do that? We don't need to implement the whole product like we're doing the first time. We just want to show that, yes, it does improve memory. If it doesn't do that, there's no point continuing. It needs to improve the memory. That's our problem. We also went, how are we going to release this? We don't want to have to do a big bang release that one day the whole product is ready and we flick a switch. So we go, okay, how do we have multiple versions in production at once, and customers can sign up to a beta program. And then we don't have to implement the whole app because we have this beta program. Customers can that are only using a subset of features can come across sooner and stuff like that. So that was sort of how we went about take 2 of the integration. So as a result, take 2, it was successful from start to end of this whole sort of project to get this new library in there. It took over a year of development with a few hurdles along the way, but the final outcome was awesome. We actually achieved what we set out to do. So for some customers, their budgets went from 3 gigabytes browser heap, basically unusable, to 100 megabytes. And that 100 megabytes includes everything else going on. So it's a huge reduction in memory. We used to be able to load budgets that only had about 20,000 rows, is when the system would just fall over and be unusable or just not load. And with the changes, we can load, though it may not be the most performant, a 1,000,000 row budget. It's sort of testing the system pretty hard, but it does successfully load if you're patient. So people typically will budget up to 100,000 rows, and there's quite a bit of headroom with the 1,000,000 rows. And this library that we set up to make, this generic component, was also successful in identifying that as a standalone feature of work that other teams could now integrate into what they're working on, so it's pretty cool. So we're seeing other teams having similar issues at a lower scale with just rendering performance, and all of these issues we had to tackle in PGM, because in React, to order large amounts of data, it's never simple. It always has performance issues. Cool. Pretty speedy run through. Any questions?
Right. Any plans for the PGM library?
Can you say that again, sorry? You just chopped in and out.
If you want, Vaughan, I can read the questions.
Work.
Great. Let me know if my headphones are making a strange noise. So the question was, any plans to open source the PGM library?
Not at the moment. It's not a particularly easy library to work with. It's very low level, sort of how it integrates with different systems, and it's very specific to Phocas requirements. So I don't know if there'd be a huge interest from the public on that particular library.
Cool. And a question from myself. So when you first discovered this, I guess, scalability issue at the very start, what between then and when it was essentially resolved, what were those specific customers with the scalability issue or with their browser memory issue? What was the situation for them? Was there kind of like a workaround in the intermediary?
There was a mixed bag. So some customers, they actually set up a more powerful machine, because Chrome could load it on a powerful laptop. It could just not load it on their laptops. So they actually remote desktop onto a machine that was capable of loading the budget. It's not ideal. It's your web-based tool, and please remote desktop onto a server to use it. Other ones is we could set filters to reduce the amount of data that we would show. So instead of having a budget that would show every organization, every branch within an organization, they could do a budget per branch and then join them together afterwards. But it's sort of, there were workarounds, but there's a lot of people that were just not able to budget the way they wanted to budget until we got it over the line.
Right. And I presume there must have been some percentage of your customers where this just simply wasn't an issue at all for?
Yeah, a lot of the customers, they don't have tens of thousands or hundreds of thousands of rows that they wanted to budget. So they were completely fine. Version 1 just worked. They were happy with it.
Great. Any more questions from anyone? Oh, another one's popped up. From Vaughan, how did you end up with larger customers?
So because it was a new product built on top of our existing code base, so the bunch of our existing customers just had larger data sets. So when we went out and said, hey, would you like to use our budgeting tool to the existing code base, some of them went, cool, awesome. We want to budget at this level of granularity, and it didn't work. So for some customers, they wanted to budget per salesperson, per product. So that was much more information than we were anticipating they would actually want to budget at. We assumed people wouldn't want to put in 100,000 sales for their budget, but it turns out people do. Yeah, so the sales budgeting was the big one when people started wanting to budget their sales or budget their product inventory.
Cool. Also a different question. Vaughan mentioned some free cybersecurity in his intro, but the audio was patchy. Would you mind repeating this? Because it looks like there's a bit of interest in that. I guess, can you give that a shot, Vaughan?
Right. Don't know if you can hear me, but is that up on the screen now?
Yep.
Cyber security, so it's through UB. So if you go to ub.ac.nz, so that's a cybersecurity micro credential.
Cool. And another question. Thanks, Ashley. Interesting stuff. What are next plans in this area?
So with the library, really, we've been able to unlock a whole bunch of features that was blocked on the old system. We just couldn't implement them because they had memory. And the development experience was people getting so concerned about memory that adding anything was just scary. It's like, oh, if we add a new field, will that remove more customers? So we have a big backlog of features that we want to implement. So one is sort of being able to budget quantity, margin, and value. Hopefully, we're probably getting it wrong. Someone will correct me later. But instead of budgeting just a number for each line item, they want to budget 2 metrics and compute the third one. So now every single cell is turned into 2 and a formula. So basically, the budget's multiplied by 3. So these type of requirements have come along since we've sort of solved this problem. So there's quite a lot of features that we want to keep implementing on this library. And we want to try to spread it wider in the organization. It just makes our whole front-end experience with all our grids just the same, which is nice.
Excellent. And another question here from Ellen. Where might you go next if, say, a significant percentage of customers wanted to work with greater than 1 million rows?
I'm not sure, to be honest. Hopefully no one wants more than 1 million rows in their budget, because I don't know how long that would actually take to do. So you'd probably have to just start chunking it up, or maybe we'd have to look at computing some stuff on the server, because the browser has just a hard limit that we can't go over. And you eventually just run into limitations. Like storing 13 million doubles is going to take 100 megabytes of memory, for example. And you can only do that if you want to go up to 10 million, that's going to be a gigabyte. And that's all you could then store. So you'd be running into other limits if you wanted to go up to 10 million. But hopefully no one wants to budget at that level. We'll wait and see.
Great. Any more questions? Well, it looks like that's it at this stage. I'll hand it back to you, Vaughan.
Right. I will try my best to talk if you can still hear me. So thank you so much, Ashley, and thank you for everyone for attending. And yeah, we'll see you at the next Canterbury event on the 2nd at